Hello guys, once again I want to welcome you all to recitation number 7, and this is about circular motion. So the wheels of a car radius 0.3 meters are rotating at 115 revolutions per minute. As the brakes are applied, the car slows at a constant angular acceleration until it comes to a stop 3 seconds later. So we are asked to find the tangential velocity of the wheel. So we'll know when a body is going around the circle, the angular velocity omega is the one it goes around. Then at the same point here, the tangential velocity is always tangent. Is that okay like that? Tangent at this point. So this is V tangential at every point. So omega is around the circle, tangential is at 90 degrees to the line for the radius at every single point. So this is supposed to go at 90 degrees like that. So that's how you know tangential velocity. So the tangential acceleration is the same direction as the tangential velocity, and the centripetal acceleration is to the center of the circle all the time. So centripetal acceleration is like that. Okay. Okay. Let's see what we have here. So sorry about that. This is loading. Come back on. Good. So we're good. So we know S is r theta. So this is linear displacement, angular displacement. V is r omega, linear velocity, angular velocity. A is r alpha, linear acceleration, angular acceleration. So this is in meters per second squared. And this guy is in radians per second squared. Okay. So this acceleration is the tangential acceleration. Is different from, and this velocity is the tangential velocity, is different from centripetal acceleration, which is v squared over r, which is omega squared r. Okay, because if you put v squared to be omega squared r squared divided by r will give you omega squared r. So this is centripetal acceleration, is different from tangential acceleration. This is what we need to solve this problem, and we know our usual acceleration is v final minus v initial over time. So we're going to do alpha is omega final minus omega initial over time. So the same kinematic equations work. So this is probably what we're going to need to solve these problems today. Okay, so having said all this, let me go straight to the problem. So first of all, we are given the angular velocity in revolutions per minute. So I have to convert that to radians per second. So I have 115 revolutions per minute, converting to radians per second. So I have to replace revolutions by radians. So 2 pi radians is 1 revolution, so revolution cancels revolution. Then I still have minute. 1 minute is 60 seconds, so minutes cancel minutes. So I have 115 revolutions per minute is 115 times 2 pi over 60 radians per second. So this will give us about 12.044, I guess, radians per second. So let's check that. So let's do 115 times 2 pi divided by 60. Yeah, 12.044. So we'll just say 12, okay, radians per second. So we are asked to find the tangential velocity. So tangential velocity V is r times omega. We have our r, 0.3 meters. Our omega is just this in radians per second. So my V tangential is 12.044 times 0.3. Is that okay? So what would that give us? So 3.61, that's what we have there. 3.6 meters per second. So average angular acceleration during 3-second interval. So we just use this omega final, so it's coming to rest, so omega final will be 0. So angular acceleration will be omega final minus omega initial over time. 0 minus 12, because we are doing the alpha. So minus 12 over 3. So this will be negative 4 radians per second squared, okay? Negative 4, because the final is smaller than the initial, okay? That's what you have there. And then tangential acceleration during the 3-second interval, okay? Tangential acceleration during 3-second interval. So we come here. So tangential acceleration is just r times the angular acceleration. So just multiply this by 0.3. So to give you the tangential acceleration. So let me wipe this off. Yeah, it's getting a little dark. I'll have to run this soon so you guys can still see. So tangential acceleration, A tangential is r times alpha, 0.3 times 4, negative 1.2 meters per second squared, because this was also minus 4 radians per second squared. And then centripetal acceleration, we know what that is. Centripetal acceleration is omega squared r. So that will be omega squared, that we just got 12 squared times 0.3. So that will give us 43.4 meters per second squared. Okay. And that is it. If you like, you could do v squared over r, or you use v tangential, which is the tangential velocity, which we got before, 3.6. So if you do 3.6 squared divided by 0.3, you get the same answer as this. Okay, it's the same result. So this is the end of the recitation. Hopefully, I'll see you guys next week. Have a good one.